Hi, I'm kenmaz from Merpay iOS team, and we'll be presenting Merpay iOS migration to GroundUp app. Here's my self-introduction, but I'll skip this time. First, let me explain what the Mercari GroundUp app is, which is the main topic, and hereafter will be referred to as GUP. GUP is a project to rebuild Mercari from ground up, rewriting Mercari's behaviors from scratch and replacing it with Bazel's fast and reliable build environment. So the purpose of this project is to rewrite Mercari from scratch, as it has been more than 10 years since the development of Mercari began, and a considerable amount of technical debt has accumulated. This project includes SwiftUI, the latest UI frameworks such as Jetpack Compose for Android, and the project also includes replacing the in-house UI library with the latest version, Design System version 3.0. Since this was a full-scratch rewrite project, we froze new functions development during this period and proceeded to concentrate on this full-scratch rewrite. Well, this was about rewriting the Mercari main application, but on the top of the Mercari application, there is a Merpay feature on it. So let me explain the migration of Merpay to the GUP. Compared to the code for Mercari itself, Merpay code has relatively little technical debt, since the development started only a couple of years ago. So it is relatively clean, and UIKit-based design system 1.5, one of the previous UI library designs, are used. Therefore, rather than rewriting the Merpay code in full scratch, we decided to minimize changes in the Merpay code with a GUP. In addition, while GUP ran, Merpay needed to develop new functions, and we couldn't stop the development of Merpay itself. So we continued the development of Merpay and during the migration time. So here is an overview of the entire project. The top row, production, shows the status of the app that are actually delivered to our customers. The bottom row is a group of codes under development internally. This GroundUp project began around April 2020. We started by rewriting only the core of Mercari in SwiftUI as a first step to solidify the architecture and overall structure. Then in October 2021, all preparations are completed, and then rewrite project began in full scale. During this phase, all the new development of Mercari application functionality were frozen, and all the development members focused on Mercari rewrite project, which continued until August in the following year. As for Merpay, as I mentioned earlier, new development were not allowed to stop, and important projects started behind the scenes. So as for Merpay, the Merpay feature set itself wasn't changed, but the code between the Mercari side and Merpay was integrated in the middle code integration layer, which was rewritten for GroundUp so that basic Merpay code remained unchanged, to ensure the Merpay's functionality is intact in both the old and new apps. Therefore, the Merpay team participated in the development of the integration layer. At the same time, the GroundUp was launched. Several important projects were underway within the company, including a renewal project to revamp the Merpay top page, a credit card project called Mercari, and the Bitcoin project called Mercoin. So the Mercari and integration implementation was completed, and the GroundUp application was released at the phase 1 in August 2022. At this point, Mercari side is all rewritten with SwiftUI, and the Merpay side still works with the UIKit. Then in October 2022, 2 months later, the top screen, this time on the Merpay side, was released as rewritten in SwiftUI, with the remaining Merpay and the Mercard features still were configured in UIKit. In November 2022, the Mercard feature was released, and the following year, the Mercoin feature, which was under development all along, was released. Phase 3 is still in progress, and we're currently working to eventually rewrite all the remaining parts made with Merpay's old UIKit with SwiftUI to eventually make it 100% SwiftUI app. So this is the overall scope of the project. So I will describe the phase 1 first, and followed by phase 2 and 3. The first is a phase 1 Merpay SDK GU app integration. The Merpay SDK, as the name implies, was developed as an SDK and designed to be loosely coupled with Mercari. And there are several reasons for this. One reason is that Mercari's functionality is handled by Mercari Corp, and the Merpay's payment and settlement function handled by Merpay side, and each company was responsible for their own development with separate repositories, as a structure of SDK is described here. There was also the idea of creating the standalone application called Merpay application, separate from the Mercari application. So it was designed to be quite loosely coupled and also have some portabilities. So this GU app integration is done by 4 processes and steps. One of the first preparatory steps is the consolidation of Merpay-related functions into the SDK. I mentioned earlier that Merpay SDK contains all the necessary functions of Merpay, but in fact, some of the functions are implemented directly on the Mercari side. So as you can see, we first transferred all of the functions to the SDK, such as the identification function, KYC, and the function for applying for transfer of seller's revenue. These were written partly in UIKit, reactive Cocoa, and partly in Objective-C, but we have written them to UIKit plus simple MVVM, which is the architecture we use at Merpay. Now that all the code is in Merpay SDK, the next step is to change the build environment setting. The old Mercari app used a Cocoa part, cottage, and a GitSub module to build the necessary code together, but the new Mercari application GU app uses Bazel to do all the build. So we needed to set up all internal and external code, including the Merpay SDK, to be able to build with Bazel. As you can see in the diagram here, the Merpay SDK and design system were also separated as a separate repository, so we imported the Google Maps SDK, Lottie animation library, Crypt Swift library, which Merpay uses and depends on, into Bazel, So they could be built together as a single Mercari application. Now that we are ready to build, so the next step is coding. Merpay has a kind of DI container called Merpay Dependency Registry. This DI container injects the functions implemented on the Mercari side for Merpay to use. So all the dependencies were gathered here. So we injected Mercari implementation into Merpay. The actual code we collected and injected include the feature flag functions, event logs, URL destinations, URL switching, deep link control and authentication, API access, image caching. Now that the entire Merpay code base can be built on the top of the Mercari GroundUp, the final step is to implement the screen transitions. In GroundUp, all screens are basically created in SwiftUI, but there's actually a wireframe layer which converts the SwiftUI screen into UIKit view with a UI hosting view controller. The UI navigation controller and UI tab bar are used to control the overall screen transitions. So in case of Merpay, the UI and the screen itself are made with the UIKit UI view controller. So I provided the UI view controller from this wireframe to the Mercari side directly via dependency registry. So, and the rest was done on the Mercari side. So the screen transition was implemented on the Mercari side. So integration is now complete. And the GroundUp application, which took about a year or two to complete, it's released. All Mercari apps are rewritten in SwiftUI, but as for the Merpay tabs, they're still in the UIKit. Integration is complete, but the future and optimization remains. One is a Git repository integration. Before GU started, Mercari iOS repository was used to manage the Mercari codes, and the Merpay iOS SDK was managed as a separate repository, and the design system was used and imported by Cartage. And after GU, Mercari codes are entirely rewritten in the new Mercari GroundUp iOS repository, and the Mercoin code is also implemented in this repository. Merpay function, some remaining function of Mercari, today's extension, and the design system code used only in the Merpay are still maintained in a separate repository and imported by Bazel. However, this was very inefficient. One reason was that the problem of not being able to directly change the code and check it since the repositories are separate. It required a very cumbersome debugging process, checking out the repository on the SDK side, editing the source code, pushing it, going back to GroundUp, and updating the repository again in Bazel and running it in a simulator. Furthermore, when we conduct a unit test of Merpay's modules, it runs on Merpay's own CI infrastructure. But since GroundUp builds everything on Bazel, unit testing on CI can be done very quickly. However, unfortunately, this infrastructure was underutilized. And therefore, in a repository called monorepo, Merpay code base and the remaining today's extension code were all moved to the GroundUp repository, and everything was developed and built using Bazel's and GU's CI infrastructure to improve development efficiency. The exception is this design system 1.5. And for the old UI libraries used only in Mercari, we maintain this as a separate repository with a code freeze.
And actually, the repository integration can be done in several ways. The simplest would be the simple file copy. The repository will copy the files, and this is the easiest. But the Git history will go away, so that was a problem. And so because of that, we want to keep the Git history as much as possible so that the source code can be moved to the GroundUp. And the way to do that is the repository integration using a subtree merging. And this is an option that's officially provided by Git. And by using this, the Git history can be maintained. But because it integrates all the repository, the Merpay wasteful, unnecessary data is also there. And those unnecessary data are merged all together. And this is not very good, because the repository gets bigger and that causes an issue. So the other solution for that is to use the git subtree command to merge part of the repository. And by doing so, although the history is maintained, the minimal code will be extracted and merged. And also the history can be maintained. However, the process is cumbersome, and there's an issue around which code to pick up. But by using this, the repository size can be maintained to merge the code. And once the file can be integrated into the repository, we do the optimization that's aligned with the Bazel build. We are changing the source code layout, or the image assets are optimized so that it will not have unnecessary data. And the Bazel build and the build, in order to use it as a build target, the modules will be defined as the Bazel modules. And during the transition, if there is a change in the old code, then that will cause a conflict. So we declare the code freeze. And by doing so, we prohibit the changes in the code to avoid conflicts. Of course, there's some errors, making a mistake in making the change to the code. So we introduce some ways to prevent such mistakes to continue with the migration. And by doing so, we spent about 2.5 months to gradually migrate the modules on a phased manner. And this is the overall schedule. And we had a total of 26 modules targeted for migration. And the other problem was that there are several Mercari function modules that directly depending on the Merpay SDK. And this itself is not a problem, but the test bundle cache gets too big, and that was a problem. And I will talk about the details later, but by having this issue, the test bundle cache gets too big, and that causes that the CI execution time or the cache storage usage volume gets impacted. And so as the SDK isolation project, the Merpay SDK DA container itself will be extracted, and we would separate that as a separate module. So that was a design change that we've conducted. To be specific, this is what we did. This is a diagram that shows the dependency of the modules, and this is the Mercari feature models. And the Mercari features are dependent on the Merpay, and so the core module uses the DA container. The Merpay core kit itself relies on the protocol buffer or the design system 1.5 module. This is the dependency. So the Mercari feature itself has migrated into design system 3.0, but because of the build dependency, it also depends on design system 1.5, and the library size is quite big. And so if we wanted to test the Mercari features, these all get booted up, and as the cache of the Bazel build cache, it would stay, and therefore causes the storage cache to get too big. And so we changed the design, and the interface for the DI container had been taken out as a protocol, and Merpay, we took that out as a Merpay SDK interface. And so the Mercari feature will only depend on the Merpay SDK interface. And by doing so, the Mercari feature itself, only the lightweight protocol module will be dependent, and we are able to conduct the unit test. And at the time of the application execution during runtime, the container injection will be injected, and the whole diagram will be used. And that was a structure change that we did. And by doing this, the test bundle cache size of the modules has lowered from 300 megabytes to 150 megabytes, and we're able to avoid the cache being too big. And we had made the Merpay SDK's minimal functions being available for a Mercari side, and we were able to clarify the SDK's debt, and we were able to contribute to the single responsibility principle. So that completed the integration project itself, and after that, after the GU architecture was released, I will talk about the phase 2, which is developing the Merpay new development screen using SwiftUI and GU architecture, and that project has started. And I would like to briefly recap on the architecture transition. In the past Mercari app, because it's been more than 10 years, there are changes in the architecture over time. Initially, it was a pure MVC, and then it moved to MVVM plus a reactive COCO, and then it moved to micro view controller plus state. So that was the architecture change. And not everything has changed. I mean, there are some old MVCs remaining. On the other hand, for Merpay, it had a very simple MVVM without third-party library. So they had a very simple MVVM architecture. And before GroundUp, there were several architectures coexisting in a single application. And after GU, in the GU application, these architecture had renewed, and the common architecture was built. And this was based on SwiftUI. And it was a single direction data flow inspired by the famous architecture like Redux and TCA inspired. And this unique architecture was introduced as a common architecture. And Mercari, a function Merpay Mercoin functions were all developed using this new architecture. And at the end, we want to integrate Merpay architecture to the same architecture. So as the first test, the Merpay top screen renewal project was planned separately, and because it's a new development, we introduced the GU architecture first. And that way the development was completed, and at this point, the Merpay tag was renewed. And on top of that, the Merpay top screen became 100% SwiftUI. Having said that, the remaining Merpay specifications existing screen are still WIP, and so we are still working on this now, but all the existing screens of Merpay will be rewritten by SwiftUI, and that is the phase 3 of this project. And now, what we had. The Merpay code had initially low technical debt, and now I would like to talk about the reason why we decided to rewrite this. Well, although it was not relatively old, it was written in 2018, and because it's in 2023, it's relatively old. And of course, it uses UIKit, and there was an issue of not being able to receive the benefits of the functions that are renewed by GU. And the new architecture or design system 3.0 and the UI library needs to be updated, and the design system 3.0 is only applying to the new GU. And accessibility support is supporting the GU architecture and also the new event logs. Well, this is more about the back end, but this is more optimized for the GU architecture. And because of that, Merpay's existing code should be moved gradually onto the GU architecture, and that was the decision that we came to. Having said that, Merpay's code, existing functions, has a lot of screen transitions, and so we started by organizing the existing specification. And we built the plan for the migration first, and we have a massive amount of existing functions specification, and we set the priorities and gradually address the migration, and that was the plan we decided to build. But we have found an issue. We have a massive amount of existing code and a massive amount of specification, and we didn't understand the relationship between the existing code and the specification. And there was some unclarity on the code, and sometimes we couldn't find the specification relevant to that code. And in the spec document, sometimes, for example, related to the Merpay top screen, some specification call it top screen, but other specification call it dashboards or payment screen. So depending on the spec, although it's the same screen, they use different wordings. And because of that, it was very difficult for non-Japanese developers to understand. So before we organized the existing specifications, all the Merpay screens, we introduced a Merpay screen ID to identify the screens uniquely. For example, MBBNK00Y, this will be the first screen. So this kind of is a ticket ID for each screen, and we decided to apply numbers to all the screens. And these IDs that are common to source code, spec, and Figma was given to clarify the relationship between all different documents to solve the gap in the understanding, and it would make it easier for non-Japanese speaking development. And this is all built into the internal development guideline, and this will get better soon. And for example, by introducing this screen ID, for example, for screen ID, if you wanted to search for a specification, you can search on Confluence to see all the documents related to that screen. And with Figma, if you wanted to confirm the UI layout, you can just enter the screen ID to confirm the official layout of that screen. And of course, in the source code, you can build the screen ID. That way, you can understand where the actual deployment of that screen is. And so based on that preparation, we built a plan, and we are now working on the migration. And each team are working separately to work on this migration. And 77% is still old, but going forward, we will spend a few years to drive this migration effort. And this is the example of the bank account screen that's being migrated. First, this is a summary, GroundUp integration project. The Merpay's function development was not stopped, but still we were able to complete the GU integration. Without changing the Merpay code, we were able to move to the new GroundUp architecture. And the basal benefit can be leveraged to the full extent in this configuration. And also the Merpay's existing functions have been migrated to SwiftUI, and in order to accelerate that, we have made improvements into different platforms, like introducing screen IDs. That will be all for my presentation. Thank you very much for your attention.